to Master's Experience Series. Thank you very much for taking time from your lunch to join us today. It is our pleasure to bring you our masterclasses virtually so that you can continue learning from wherever you are. If you find our sessions useful, please feel free to share our Facebook videos with your family and friends. So in view of time, let's begin. Hi everyone, good afternoon. Welcome to Master's Experience Series brought to you by HeadHunt in partnership with National Institute of Education, NTU. Broadcasting live, we have with us Dr. Hiron, who will open the session with an overview on NIE's graduate program. Thereafter, we will have Assistant Professor Farhan Ali, who will be sharing on the topic of Science of Learning. Before I hand over the time to our speakers, please note that there is a Q&A function at the bottom of your screen. Please feel free to type in your questions at any time during the presentation. Please also note that we will be conducting our feedback poll at the end of the session, so please stay with us throughout. Without further ado, I'll now pass the time to Dr. Hiron. Dr. Hiron, over to you, please.
Thank you so much. Good afternoon, everyone. My name is Dr. Hiron, yes. Let me share my slide first. If you're able to see my slide, please see something, yes?
Yes, it's good.
Okay, great. Okay, before we have Dr. Farhan to share about our newest program, master's program, I would like to just spend about 7 to 10 minutes just providing kind of bigger context with regard to our NIE graduate programs. Okay, without further ado, let's proceed. Okay, I think on the whole, I mean, you're here, I'm sure you're asking yourself, why do I want to do a master's, right? I know some of you are a bit sure that you want to do a master's. Some of you are not so sure whether you want to do a master's or not. Some of you are very sure you want to do a master's, in particular with this science of learning. So I just want to state outright, upfront, that if you are done your degree is just the first degree only. And you know that the world is changing very rapidly. And some of us may say that, yeah, I can learn on my own. I don't need any kind of a structured program. But, you know, it's important that part of the structured program is actually gives you the kind of efficiency that will help you to learn better. So a certificate is more than just a piece of paper. It is definitely a signal that you have acquired much and you have attained a certain level. Of course, lastly, it pays to study, right? You know, Warren Buffett would say that the best investment that you can make is investing in yourself. Okay, so education is important, right? If you think about it at the national level, you know that this is part and parcel of the skills future, lifelong learning and all that to enhance your employability and your mobility, whether you move sideways. I'm not talking about your size of your body, but whether you can go from one industry to another industry, or whether you want to move upwards. Getting some kind of certification and qualification is of value. And of course, equity. You know, some of you may think that, oh, gee, I want to catch up. You know, now is a good time for me to catch up with where I want to move up in a certain way in life. And last one, survivability. What it means is that if you improve yourself individually, you actually is a contribution to nation building. Okay, at NIE, we offer a lot of master's programs actually, altogether 30. In fact, NIE school provide the largest number of master's programs. And within our master's programs, we categorize them into different types: academic content, education, and professional practice too. This is just a list of them. You can go to our website and take a look. Of course, our newest is really the Master of Science, Science of Learning, in partnership with Lee Kong Chian School of Medicine. So we started ours this year, January. So the next one will be in January next year. Please look out for that. On top of our master's program, we also have our micro credentials. We have our graduate certs and also the Flexi Masters. So this courses should be taken as standalone individual courses prior to going for your masters. I mean, of course, if you don't want to do a masters, it's fine, but you can get your graduate certs or Flexi Masters. They themselves are these are in themselves certifications. But usually when people take these courses, they have the intention of wanting to do the master's program. There are advantages to it, partly because when you do your micro credential, you can space it out a bit. There's flexibility in spacing out. There's flexibility in terms of funding also. I mean, if these courses are SDG funded, you're able to cut certain costs before you go to your master's programs. Okay. Why micro credentials? Partly because it's flexible. I mean, the flexibility is there. It's competency based also. Some of our micro credential courses are meant to pitch it at the practice, to improve your practice. Yeah, and it's stackable in that sense. Okay. But the main thing there is that picture there, SSG funding. Okay, and NIE, we have offer courses at our place. Okay, so you may want to visit. These courses may or may not be at the master's level. For those of you who are not so keen to do the master level courses. Of course, some of you may think that, okay, so I want to do my master's. Some of you are considering even to go beyond that, whether you do your Doctor of Education or Doctor of Philosophy. I know some of you may be asking, why do I do what's the difference between Doctor of Education and a Doctor of Philosophy, a PhD versus EDD? Is that in EDD is more practice-based, and let me see, research is when you do a PhD is more independent supervised research, and when you do an EDD is much more structured for you, where you have more courses for you to take, and those courses serve to help you, move on to do your dissertation work. Okay, and lastly, I just want to share to you the registration period for the January 2022. Our next registration period is January 2023. So these are the dates. So please continue to look at our websites to look for updates. So this is where I end. Thank you so much. I shall now hand over to Dr. Farhan for the next presentation. Thank you so much.
Right, thank you so much, Dr. Hiron. Let me share my slide. Okay, I hope you can see my animated picture here of
yes
neurons in the brain, nerve cells in the brain. Okay. All right, so good afternoon, everyone. As mentioned earlier, my name is Farhan, and I'm from NIE, part of NTU. Today, I'm pleased to share a bit of what we cover in one of the core modules for our Science of Learning degree program. The picture on the left is a conceptualization of what science of learning is. We'll cover that in a few slides, but I want to focus on the GIF on the right that you saw earlier. So these are images taken from a living brain of actual neurons or nerve cells in the brain firing away. Whenever you see flashes, the nerve cell is active and transmitting electrical signals. To give you a sense of the scale, this is the width, not the length, but the width of a human hair, strand of human hair. So these are very small structures in your brain. If you're wondering about the mysteries of the brain, this is it. This is all there is to the brain. Bunch of electric nerve cells buzzing away for us to think, feel, and learn about the world around us. So I just thought of sharing this image that I typically share with my students. This is an overview of the talk today. We'll cover what science of learning is, then move on to factors affecting learning before examining some of our beliefs about the brain, mind, and learning. I'll round off with some information about our new master's degree program, Science of Learning. So what is science of learning? Simply put, science of learning is an interdisciplinary approach to understand learning. Here, I'm showing you one conceptualization by leading researchers in this emerging field. They saw it as an interdisciplinary field contributed by psychology, neuroscience, machine learning and AI, and of course, education. So why is there a need for multidisciplinary approach or interdisciplinary approach? The idea is that something as complex and multifactorial as learning needs to be understood and studied from a myriad of different perspectives, so as to integrate the different levels of understanding. So this is an image I'm sure you've heard about this proverb of different people being blind and feeling different parts of the elephant and seeing a very restricted picture. So we use this as an analogy of what science of learning hopes to do, which is for us to have a better picture by looking at the phenomenon of learning at different levels, different perspectives. Here I'm showing you some of the nagging questions that educators and leaders face that we hope can be addressed from a multidisciplinary perspective. These are the hard questions. So for example, can we develop self-motivated learners, or how can we harness emotions for better learning? So these are hard questions that a lot of educators and teachers and trainers and so on are interested in, and there's no easy answer, but we hope to get closer to good solutions by using science of learning approach. So how different is science of learning from, let's say, education? It can be quite different. So science of learning is focused a lot more on learners, whereas in education, traditionally, it's focused on teaching, instruction, and curriculum. Of course, in the last decade or two, that's changed a bit more. Science of learning, there's a lot of emphasis on the role of brain science and cognitive processes, whereas in education, there's quite a fair bit of socio-cultural perspective. So I like to use this quote by Leslie Hard, a psychologist who argued that designing educational experiences without an understanding of the brain is like designing a glove without an understanding of the human hand. So I think you can appreciate how succinct this statement is in capturing the importance of understanding brain and cognitive processes in education. Well, of course, trainers and educators are not expected to be experts in the brain. Some knowledge, I think, can be useful. So again, science of learning is quite different from, say, traditional fields of education, with its emphasis on data and evidence-based practices, as well as its multidisciplinarity. There's been tremendous growth in science of learning in the past few years. Here I'm plotting in blue the rise in the number of publications that have used the term learning. So there's been a rise. Interestingly, there's been a dip in the last few years. And I'm superimposing the plot for the term science of learning. It's a lot smaller, but you can see the growth being somewhat exponential in the last few years. So there's strong growth in interest in science of learning. And globally, there's also been new journals and conferences on science of learning, as well as universities pioneering new programs that combine mind, brain, teaching, and education. These are just some samples. Recently, there's also been interest in the popular media, such as Time Magazine's special issue on science of learning, as well as some books that some of you may have heard of or even read that have tried to popularize the importance of understanding the brain and how the mind works in order to improve learning and teaching. So that's a very quick overview of what science of learning is. Hope you get some sense. And now we're going to move on to the meat, so to speak, about learning. So factors affecting learning is what I'm going to start off with. So here's a schematic of some of the factors I'll be covering that relates to neuroplasticity and learning. So movement and physical activity. All right, let's cover the first thing. So why do you think we have brains? If you ask ourselves, right, why do we have brains? It may seem obvious. We need to have it because we need it to think with, right? Important for thinking. But the humble truth is that all animals, as shown here, pretty much have a brain. So the function of a brain must be more basic and common to all animals, right? So it turns out that the brain originated as an organ for moving and interacting with the surrounding world from hundreds of millions of years ago. This is conveyed quite dramatically by the humble sea squid. So it has an initial life phase when it's mobile. I'm not sure if there are biology teachers in the crowd, but when it's young, it's mobile, it moves around, it has a brain. But when it reaches adulthood, it sticks itself to a rock. So it becomes sessile, what's called sessile, and it doesn't move. So this is when it eats its own brain as food because there is no need for a brain anymore. That's sort of an anecdote to capture the importance of brains. That's originally what it's designed for moving around and interacting with the world. But of course, we now use it for many other things. Fundamentally, that's how the brain evolved initially for moving. So what does this mean for learning? It means that movement and physical activity are all natural ways of how the brain develops, and this positive development can have effects on other functions, including for learning and education. So this is strongly supported by empirical data. Young children in preschool, so 4 or 5-year-olds that have good fine motor skills as well as good gross motor skills have much better academic achievement at grades 2, 3, 4, and so on. So here I'm showing you the actual correlations. You don't have to worry too much about the numbers. But the point is, if you have an early head start in moving, in physical activity and so on, you're much more likely to function positively in academics. So the brain mechanisms are still being researched, but it's likely due to the positive effects on children's visual spatial skills and other functions such as attention, goal, pursuit, and so on. The idea of learning by doing associated with better learning outcome is also supported by experimental studies in psychology. So the experiment goes like this. You're asked to memorize phrases. For example, memorize the phrase, draw a line. If you then enact drawing out a line, so like physically move and draw a line, you are much better able to remember that phrase when you're tested later on. Compared to when you are just verbally saying it out loud, say just verbally saying out, draw a line. So the effect is at play when teachers do active learning involving moving about, trying things physically and so on. And the good thing is that this all have basis in neuroscience and psychology research. All right, now let's move on to the role of sleep. Okay, sleep is something that we think is not important, but the empirical evidence is again quite clear. In one large-scale study in China involving tens of thousands of primary school students, those who have an optimal number of hours of sleep, over here around 9 to 9.5 hours of sleep every night, they had much higher levels of attention as shown here. And those that slept too little or too much had lower levels of attention. These are primary school students. The study also looked at other measures such as memory and mood and so on. There were similar effects. You need a certain optimal level of sleep in order to function in school. That's for children. In adulthood, there's also a strong positive relationship between sleep quantity and quality with work performance. So here's a meta-analysis. Meta-analysis is when researchers combine results from many studies, not just one. You don't have to worry about this complicated graph. But the main point I'm trying to make is that good sleep, both quantity, so the amount of sleep you get, and quality of sleep can contribute to positive feelings, better job attitudes, and cognitive resources such as performance, which all then positively affect task performance and behaviors related to work. Even Jeff Bezos, the multi-billionaire who's got more in his bank account than we can all even count, believes that getting 8 hours of sleep is important for his own work performance. So you may be asking, how much sleep do Singaporeans have? So it turns out that we have the lowest amount of sleep compared to all the other developed nations. So Singaporeans basically work too hard and sleep too little. So how is sleep important? So sleep plays a role in memory consolidation. So this figure on the left shows a measure of memory recall. So the higher the number, the better you're able to recall what you just learned. And in the black bar, individuals who slept normally after they've learned something new, and then they were tested a few days later. And in the gray bar, the individuals who were sleep deprived. So they didn't have a chance to sleep well, and you can tell that they are less able to remember and recall the information. So the mechanism for sleep being an important player in memory, learning and memory, is quite clear when we learn something during the day, wakefulness, and then when we sleep. What happens is the sleep allows us to consolidate the memory, which is now distributed all over the brain, particularly the cortex, the outer layer of the brain. And that allows the memory to be more stable after we wake up. And if this process is prevented or affected by sleep deprivation, our memory of what we just learned is less stable. We're not able to better remember it. So lack of sleep has been shown by brain imaging to affect brain functional connectivity. So these are pictures of areas of the brain by individuals with normal sleep. So this is the left hemisphere, this is the right hemisphere if you're looking from the side. And the hotter colors, hotter being red and yellow, indicate areas that are highly connected. So these are areas that are forming highways, so to speak, to form connections to other parts of the brain. And after a single night of sleep restriction, so individuals in this study could only sleep for 4 hours, the brain becomes less connected when you're sleep deprived, and it explains why we're not able to remember as well, since we are less able to store and recall our memories using connections in the brain. So if you sleep less, you basically have more disconnected brains that hinder your own learning and memory processes. All right, I'm going to move on to diet and nutrition. It's well known that diet and nutrition can affect early schooling outcomes. Factors that promote early schooling outcomes include regular breakfast, high quality nutrition, as well as dairy, so milk, for example. And factors that negatively affect early schooling outcomes will be skipping breakfast, eating energy-dense diet, and junk food. It's pretty well known. So diet and nutrition likely affect learning via neuroplasticity, so how the brain organizes and grows during early development. So this is an early study to illustrate the importance of, for example, breakfast on learning performance in 10-year-olds. So these are primary school students. So if you have primary school students coming into the lab, for example, and not have breakfast, what happens is that their mental processing declines throughout the rest of the morning. So going from 9 a.m. to 10 a.m. to 11 a.m., it goes down. So the bars go down and they become slower in their mental processing. This is without breakfast. But if the children had some cereal breakfast before coming into the lab, the decline shown in the shaded bars is less severe. So they still get slower in their mental processing, but not the decline is not as rapid. So they don't lose focus as quickly as those without breakfast. So breakfast is good, basically. In terms of mental processing. And in terms of brain mechanisms, it turns out that if you have breakfast, you allow your front part of the brain to be more active. And this front part of the brain is pretty important for functions such as attention and memory. It's an fMRI image of this front part that's activated a lot more when you have breakfast. So what if you look at these factors and think a little bit more? They are suspiciously important for other parts of our body, right? If you think about it, I mean, movement, physical activity, diet, nutrition, I mean, those are important things for the heart, for example, right? And it's true, these factors are quite common as being factors that affect other organs, because the brain is really just like any other organ. It's affected by the very same factors that affect other organs like muscles, the heart, and so on. So this is a point I'm trying to make. If you think about school and education, we think of a building, a compound with teachers, teaching materials, and so on. But I personally think these are just facades, right? Superficially, that's what is happening. But what really is happening is basically teachers are neurosurgeons. So what's going on is that teachers are operating non-invasively, of course. You don't open up the skull, but you're almost like neurosurgeons trying to shape the brains of our children in subtle ways. But this process is happening to an organ that's also affected by many other factors that affect organs in the body. For example, sleep, diet, nutrition, and so on. So I bring this up to emphasize the point that teachers in a traditional educational framework teach, but teachers in science of learning framework, they are doing an intervention that's affecting an organ, and that sort of wider view makes us appreciate how difficult it can be to produce desired results in education, because all of these other factors that affect how our organ learn, our brain as an organ learns, so, sort of can interfere with what we're trying to do in the classroom. Okay, let's now move on to beliefs about the brain and mind. Let's do something more fun that involves a bit more interaction, because that's what we normally do in a physical classroom. Unfortunately, we are only able to do Zoom now. So what you can do is you can take out your smartphone. I'm sure everybody has a smartphone given this situation we're all in right now. So take out the smartphone, scan this QR code to go to this website, or you can go to menti.com and put in this code 54553752. So two ways: scan this QR code, or on your phone or desktop or laptop, go to menti.com and put in this class code. So let me just stop sharing, and then let me share the class code again. And start the Menti. Okay, excellent. We have, 15 people joining in. So again, go to menti.com and type the class code 54553752. Menti.com 54553752. The class code is on the chat. You can just copy and paste it on menti.com. And we have a lot of people joining. Let me just share my other screen. Okay, can you see this screen of avatars or icons? There's like a football, a frog.
Yes, yes.
Yes, okay, thank you. Thank you, Dr. Harun. Yes. Okay, so again, go to menti.com. I would like as many people to participate as possible. Menti.com, and on the chat, you'll see the class code 54553752. Okay, I'm going to start. So what you'll see will be questions, and then try your best to say whether you agree or disagree with the, sorry, not questions, these are statements. So I'll give you statements about the brain, the mind, and how we learn, and then you share whether you agree or disagree. And the correct answers get points, and then we'll see who who's number 1, number 2, and so on at the end. So again, menti.com, class code is in the chat. Okay, let's begin. So we have about, I think, probably 20 or so. 30. Oh, actually, we have quite a number, 35. Awesome. Okay, let's begin. So first question. All right, so that's the first question. And very soon we'll see the results. Interesting. Agree. Majority agree that we only use 10% of our brain. And it turns out that that's not true. So the ones who disagreed, congratulations, you got some points. Okay, let's move on. Next question. So again, I think you're getting the drift of the game. Statements and then agree, disagree, or don't know. All right. Almost everybody has punched in the answer. So what do you think? Agree? Left brain, right brain? Again, majority agreed. But again, that is wrong. The left brain doesn't work differently from the right brain. So good job for the ones that disagree. All right, let's move on. Next question. It's a bit silent. I should have turned on the music. Oh, here we have an even split, but so again, research suggests that emotions do not necessarily negatively interfere with thinking, learning. I'll show you some data. All right, let's move on to the next question. Okay, so what do you think of this? What's the answer? I think you're seeing a pattern here. So again, majority said they agreed, but the scientific results disagree instead with what we think is happening. Okay, last question, chance for you to catch up if you've gotten too many wrong answers. Okay, this one is simple, right? I mean, it's straightforward. It seems pretty obvious. Okay. Oh, wow. I've been proven wrong. I thought everybody would agree, but again, the research suggests that no, you don't necessarily learn better if you just read and read your lecture notes multiple times. Okay, great. Let's see who's number 1. Oh, wow. We have a snowman who's at number 1. And a watermelon and a bee. Oh, there's a donut. So Meza, MN and B, congratulations, and the rest. Okay, let me just what's in the next slide? Actually, there's the leaderboard again. Okay. So great, that's sort of a little activity for you to get involved. And I'm gonna go back to my slide. Give me a second. Okay, so I hope you can see my screen again, my PowerPoint slide. So what we're going to do is we're going to go through each of the statements, and then we're going to unpack it and then see why I said a lot of beliefs that we have about mind, brain, and learning and so on, they're wrong. So these are neuro myths, these beliefs that do not have good scientific basis. They are based on folklore, rumors, and misinterpretations and misunderstandings. So Hollywood is one good purveyor of neuro myths, right? For example, in the movie Lucy, I love the movie, but it's completely inaccurate. You have this character played by Scarlett Johansson who takes a drug, I think a pill, and can start using more than 10% of her brain. So she becomes a genius who can learn new languages in seconds. And when she starts using 100% of her brain, allegedly, she can even do ridiculous things like mind reading and travel to different parts of the universe. So I call this neuro myths neuro zombies, because these are things that just refuse to die. So is it true that we only use 10% of our brain? This is false. So I'm just giving you one example. So I'm showing you fMRI images of native speakers of Mandarin. So these are essentially people in China writing Mandarin characters. Research by Young et al. So here's a left view, side view of the left brain, side view of the right brain, and the hot colors represent areas that are active in writing Mandarin characters, compared to when the subject is resting, just resting. So you can see huge swaths of the brain being active for something as simple as writing a character, a Mandarin character. These are native speakers writing Mandarin characters. They've probably done it billions of times. And you use up almost half of your brain. So you probably are aware of fMRI. It uses magnets to track oxygen levels in the brain. And when you use a part of the brain for something, you need more oxygen to power the activity. So you see signals corresponding to how active that part of the brain is. So in general, the brain is a very expensive organ to maintain, despite being very small. It's the size of about 2.5 fists or so. So you clench your fist, that's about the size of your brain. It consumes a tremendous amount of energy, even at rest and during sleep, because that's because the brain is actively working. It's using a lot of energy because it's actively working, even when you're sleeping. So it's not true that we only use 10% of our brain. We probably use much higher proportions, probably close to 100% at any one time. Yeah. So another neuro myth that you saw in the quiz is that we have a left brain and a right brain, right? So the story is that the left brain is more logical, right? More factual and so on. And the right brain is more emotional and creative. So many times this idea is propagated by people trying to sell products such as books and enrichment activities. For example, this website. So again, what does the scientific research show? So brain imaging suggests that math, for example, involve both the left and the right hemisphere. So this is a top view of the brain. If you imagine being high above and looking down. So this is the left brain and this is the right brain. And the colors represent areas that are important when you do computations. So for example, 2 + 5 versus when you're reading. And you see both left and right hemispheres being active, left and right, left and right. So it's not the case that doing math is localized to the left hemisphere. Now you may then ask, hey, doesn't this show that we only use 10% of our brain? So not quite. The image here is comparing compute, what they call compute or doing math, versus reading. So only areas that are specialized for doing math or computing would light up, so to speak. In actuality, if you show all the areas involved in computing compared to just resting, a lot more areas of the brain are involved. So research papers usually omit those images that compare doing something like doing math versus resting. They compare it usually with another condition that's active. So if you don't get that, maybe this is a bit more intuitive. This is about emotions. The study looked at parts of the brain that are active when you experience certain emotions. And the dots represent areas that are active. In green would be positive emotions, and in red negative emotions. And this is the right hemisphere and this is the left hemisphere. And you can see that dots all over the left and all over the right. So again, emotions are not localized to the right brain. The right brain is just not more emotional. The left brain is also processing a lot of emotions. So this is the left, if you can get your left and the right correct. Okay, so that's another neural myth that has very little support in scientific research. So I want to move on to the third statement that you saw in the quiz. Emotions negatively interfere with thinking and learning. I think we have this idea that emotions is something that we need to tame. But let's go through this simple card game that's used in actual research. Yeah, so this is not just any game; it's used in actual research. So imagine you have 4 decks. So if you play poker or hopefully gamble socially, just socially, you'll be familiar with poker cards. So you have 4 decks, right? And then there are cards in each of the decks, and your task is to keep picking cards from any of the decks, and then you are given certain rewards when you pick a card from a certain deck. So for example, if you pick a card from deck A, you get $100. If same goes for deck B, if you pick a card from deck B. But if you pick a card from deck C or D, you only get $50, right? So they're not as good. So if your task is to maximize or make sure you earn as much money as possible, it's quite obvious which card which deck you will start picking cards from, right? You will pick cards from decks A or B because they give you a lot more rewards. So you continually pick cards from A or B. But what if I told you that for every 10 cards that you pick, you get punished by having to return some money, right? So there's some loss. So if you pick cards from decks A or B, occasionally you get punished by having to return 1,250. But if you pick from decks C or D, you only need to return $250 after 10 cuts. So maybe think a little bit more, given this situation, which deck would you want to pick from? If you have a choice of picking cards from the decks, which deck would you try to pick from? So maybe this might help. So let me look at the chat. No. Chat is full of questions. Okay. So if you think about it, you obviously want to pick from the decks that produce the best profit, right? So take the gain minus the losses, and decks C and D punish you less. Even though they reward you less, they punish you a lot less, so you get more profits from decks C and D. So there's a website, it's called the Iowa Gambling Task, that you can try and see whether you can discover which deck is the good deck. And most regular people would pick from decks C and D because they learn that they get more rewards, like they get more profit. So this is a task involving decision making by combining evidence. You're combining evidence about your gains and your losses. And that's what happens to normal people who are called control participants. They learn that decks C and D are good decks and they start collecting more and more cards from C and D, right? So over time, they select from decks C and D in squares, and they select less from decks A and B. These are for regular individuals. But it turns out that if you do this same task or game with patients who have damage in the front part of the brain, they are not able to learn which deck is the good deck. These patients have problems using their bodily sensations to guide their learning and decision making. They lack emotions, especially social ones. They don't feel guilty, embarrassed, and so on. And they have problems trying to learn which deck is the good deck to get more and more cuts from. And this is a plot of sweat levels. So during this experiment, you can monitor the sweat levels of these people on their hands, a bit like Fitbit, where you can sense how much sweat you have. And regular people individuals in the control group, they have this sense of nervousness when they try to take cuts from decks A and B. Remember, decks A and B are not good decks. You get punished, right? And they have some, they sense this nervousness and they sweat more, shown in the gray bars for normal individuals. But for individuals who are not able to feel emotions and not able to learn how to make good decisions and pick from the good decks, they don't feel that nervousness, that sort of that sweat, and sense it. So this is a classic study from some years back, but it's classic because it sort of revolutionized the field and provided strong scientific evidence, among the first, that you need emotions to think and normally and make good decisions in this simple game. It's a simple game, but you can extend it in many different ways. And I'm sure we have teachers in the crowd who would agree that emotions play a very big role in thinking and learning. So we have evolved from sort of the thinking of early philosophers like Descartes. I'm not sure if there are philosophers in the audience. Descartes, who argued that the essence of being a human is being able to think, right? But the more modern version is that argued by people like Imodino Young and Damasio, is that we feel, therefore we learn. So you go from I think, therefore I am, to we feel, therefore we learn, arguing the feelings as a basis, a strong basis for learning and thinking. Okay, I don't quite have time to go through the other neuromyths related to learning styles and reading lecture notes. This is where I would like to invite you, if you're curious enough, to consider joining us to be better learners and educators. You can visit our degree program website, shown here. You can scan this QR code or go to this link. You can also watch a program video via this QR code. What's unique about our master's degree program is that you get to learn from a diverse multidisciplinary group from both NIE as well as our partner NTU school, the LKC School of Medicine. So these are some of our wonderful instructors you'll get to learn under, and there's many more. At this point, I'll be happy to field questions. So this is your chance to clarify some doubts or questions you may have. I'm hoping we can have a more interactive session. We do have a decent sized crowd, but not too big, so nice and cozy. Feel free to ask questions. Okay, there are quite a number of questions in the Q&A. So the Q&A is where you type your questions and we can address them. Okay, let me just go through them quickly. All right, so Pei Lim asked, hi Prof, thank you Pei Lim for your question. So the myths about left and right brain 10% usage and so on, are they all completely wrong? Or is there some truth, but only a little? Or no, my life has my life been a lie? So yes, so the thing about myths, right, is that they may have some basis in truth, right? So the phrase is that no smoke, no fire, no smoke, or something like that, right? So there is some basis. So there are functions in the brain that are lateralized. So the left brain, for example, would specialize a bit more, for example, in speech and so on. But the vast majority of functions in the brain require coordination between the left and the right brain. As you saw, doing math, feeling, emotions, and creativity, playing the piano, a lot of these functions, important functions, right? They require both left and the right brain to coordinate. So that's a lot more important. So 10% usage. So again, at any one time point, the brain is being used a lot more than just 10%. So I think the myth, I did some research, originated from potentially Einstein, or maybe I'm misattributing it. The idea is that he thought we were not using enough of our brain, maybe someone else. But the idea is that the brain is so expensive, it doesn't make sense to have such a big organ that uses a lot of energy if we're not using it. So the truth is that we are using it even when we are resting, even when we are sleeping. Sleep is not a state of rest for the brain, actually. It's a state of activity. It's just a different kind of activity. Our brain is very active when we're sleeping. It's just different from when we're awake. The kinds of activity is just different. So I think there's some nugget of truth in some of these myths, but by and large, they're sort of wrong, or they're just myths. Yeah. Okay. Thank you so much for asking that question. We have a lot of questions coming in. Good. Please keep coming at me. We have quite a lot of time. I cannot promise that I'll be able to answer everything or answer them to your satisfaction, but at least I can give you some sense. Okay, so Julia Sia is asking, is it only number of hours of sleep, or the time of sleep also has an impact? What time you sleep and wake? Yes, good question. So it's both quality and duration. So both quantity and quality that matters. But like everything in life, you need to have a certain amount of minimum quantity before you can have quality, right? I don't think there's such a thing as 3 hours of quality sleep. I think it's quite clear from neuroscience research. There's no such thing as, a small amount of quality sleep. You need a certain minimum. And in general, for adults, it's usually 7.5 to 8 hours. For children, it's a lot more. Yeah, typically it's like 9 to 10, closer to 9 to 10. Yeah, my children all go to bed by 8:30, and they wake up at 6 plus. So they get a lot of sleep that I think helps the plasticity in the brain and so on. So again, these are not just beliefs. These are like extensive evidence from the literature. Sleep routines, like the time that you sleep and the time that you wake up, I think that also helps a lot. Yes, so you're better able to sleep when you have a sleep routine. Yes, if you sleep consistently at the same amount of time, at the same time, and then wake up at the same time. Yeah, that helps with getting into the rhythm. Yeah. There's another question by Ganesha Murthy, SG, I think. Yeah. Is sleep equal to meditation? Which is, does one get sleep deprived when one's meditating? So sleep and meditation, they're not necessarily the same state. Yeah, I'm not sure if people have looked at this, but I would argue that they're different states. Yeah, sleep is a very unique state. When we sleep, we go through various stages. Actually, there's a stage in sleep that's called paradoxical sleep, when the brain looks like it's actually awake, but then we're physically sleeping, but the brain, if you just look at the brain, it looks like it's awake. And that's typically when we start to dream. That's different from meditation. I think meditation has different signatures or hallmarks. So those are different things, and maybe you're hinting at, can we meditate instead of sleep? Can we say compensate the lack of sleep with meditation? I don't think so, because the two are likely to serve different functions. I'm not an expert in meditation, but sleep has very unique functions in sort of helping the brain learn, which may not be the same as what goes through the brain when you are meditating. All right. Let's see, we have more questions on sleep. There's a lot of questions. I'm very pleased to see them, but it also makes it quite difficult to go through. Maybe I'll just do it sequentially. Okay, so TK is asking, is memorizing, recall the same as learning, understanding? So learning is just a general phenomenon. Based on neuroscience research, the definition of learning is just experience-dependent change. in thinking processes, in behavioral processes, and so on. So it is dependent on experience. So you don't just learn in the classroom, you also learn on at the playground, you also learn when you play video games and so on. So learning is not the same as being in the classroom. So as long as you change your behavior because you've experienced something new, that's considered learning. And learning can operate at different levels. So at a very basic level, you might learn facts, right? So the capital of France is Paris, for example. These are called semantic memory, semantic forms of learning, but there are also higher forms of learning, so to speak, where you start integrating information and organizing the facts. So there are different levels of learning, but memorizing and recall is sort of one level. Okay, so regarding breakfast being important for the brain, which can be contradicting. So Chun Yung Lai is asking, is having breakfast contradictory to good diet approach, which is 2 meals a day or even 1 proper meal a day, etc.? What's your view? Great question, because I am practicing what's increasingly called and increasingly popular called intermittent fasting, where you're starving, almost starving your body by limiting yourself to just 1 meal. And it turns out that a lot of scientific evidence suggests that that has got very positive effects. One of the main drawbacks of living in a modern society is that there's so much food and so much carbohydrate and so on, and all those things actually have very detrimental effects. When you try to limit caloric intake, right, you don't have to diet, as in you don't have to pick and choose, or I can only eat, you know, vegetables but not meat and so on. No, you just eat whatever you want 1 time a day. And I try to do it breakfast in the morning. And I mean, this is again anecdotally. I think that's something I practice, and the research is quite fascinating. Yeah, that can have positive effects on cognition, on health, and so on. As to whether it's better to do breakfast versus just lunch or dinner, I'm not sure. I'm not familiar with the research, but I personally feel breakfast might be the best. If you just have 1 meal a day and it's dinner, you might not be able to digest it, and when you go to bed, right, you're not using up that calorie, right, because you're just resting. So that might not be as beneficial as having restriction to just eating in the morning. So this is anecdotally, I'm not an expert in nutrition, but based on the evidence that I've looked at in the scientific literature, you know, limiting caloric restriction can have positive effects on overall health. Okay. So we have a question here related to the program, and I think this is where Hyron and our graduate office can come in as well. So Weng Hong Lo is asking, I'm sorry if I have your surname and family name and given name mixed up, because Zoom, you know, sometimes switches all this around, but there's a question about what are the demographics of alumni from the course. So it's a new program that just started. We have our inaugural batch, which is quite large relative to other programs in NIE, almost 30 students. About 30 to close to 35 to 40% of our students are MOE teachers. So these are highly trained educators teaching in public schools, so primary schools, secondary schools, and so on, but they're just 30 plus to 40% of them. The rest are a mix of people with interest in education. They may also be educators, but they may be teaching in the private sector, for example, tuition centers, or they are therapists providing language therapy or behavioral therapy, but broadly interested in education. There are also STEM people, so science, technology, engineering, and math people doing programming, doing technology work, and so on. So I think it's a unique, diverse group for you to learn from, not just teachers, MOE teachers, but also majority are non-teachers who are interested in education. Maybe I can also try to highlight questions about the program and graduate education in general, so that Hyron can come in. I'm not sure if Hyron is seeing any questions about.
Actually, I think most of them are about the science of learning.
Science of learning.
I think Sherry is already handling some of the queries on the program. I think one of the questions that caught my eye is in terms of career options after taking this program, you know. I recall seeing that. Maybe you want to.
Yes.
That, yeah.
Yes, I did glance at that. In terms of career prospects, okay, so this is our hope. Our grand vision is to develop a new generation of teachers and educators, not just highly skilled in curriculum, highly skilled in instruction and teaching and so on, but have a broader view of learning. They know how the brain and the mind would work. They know the psychology of learning. They know how to use technology effectively. They can apply, data analytics and so on. Our course has a very strong data component. There's a course on AI. There's a course on using data for learning analytics. So this new generation of learning designers who can bring in sort of knowledge and expertise from these different fields to develop sort of more holistic learning experiences and learning environments. So that's our grand vision. So we expect our graduates to still be in the broad area or industry of education, either teaching in public schools like primary schools and secondary schools and so on, but also in the corporate sector, doing corporate training, adult learning or adult training. We do have quite a number of people in healthcare. They are interested in going into healthcare education. So these are, again, highly skilled healthcare healthcare practitioners, but they are interested in trying to train the next generation of healthcare practitioners and being able to learn, being able to understand how we learn and how we can teach better will be helpful in their transition. So those are sort of the broad career areas that I think our alumni are going to go into. But again, our program is quite new. We're hoping to develop the alumni network very soon. Yeah.
Yeah. The other question that I want to surface is in terms of delivery, right? Mm-hmm. How blended is the courses in terms of blended learning? Or can we assume that most of the courses are face-to-face or?
Yeah, thank you so much, Hiron. Good question, given the situation or the new worlds, a lot of people saying with the new world we're in, right? I would say that we do incorporate blended learning quite nicely into the whole degree program. Some courses have more face-to-face components. Some courses balance it a bit more, 50-50, face-to-face and Zoom, for example. I think it depends on the course, but be prepared to experience a lot of interactions in classrooms, interactions in active learning in our learning environment in NIE. We just finished a class that had students walking around the campus doing activities and so on, because I think that's part of the learning experience, getting together, forming networks, discussing and so on. I have received feedback that students don't feel it's worth paying so much if they're just going to sit, in front of their screen for hours and hours for 2 to 3 times a week. I think they want to get out and learn in a more diverse manner, right? Coming to class, doing projects, meeting other students and so on. Having said that, I do understand constraints that individuals have about traveling to NTU, also work commitments and so on. That is why, depending on the course, our instructors do a good job of balancing Zoom sessions with face-to-face classrooms and so on. So as you enroll and register for the courses, you have an outline at the very beginning. It tells you which sessions are in which format and mode, and then you can sort of organize your life. Yeah. I hope that helps with the mode of learning.
Yeah, thanks so much.
Okay. I'm trying to see how much time we have. It's 1:05. Maybe we can take a few more questions. Is that okay?
Yep, it's good.
Jamie, good. Okay. Okay, Matilda Huang is asking a very interesting question. Do you think reversing brain aging, especially in functions, is possible, and to what extent? Great question, Matilda. So increasingly in the last few years, there's this concept of brain age, which is potentially different from your chronological age. So I am X number of years, right? Chronologically based on my date of birth, but I'm not sure what my brain age is. So there's been research looking at the differences between brain age and chronological age, or age in years. And the two do not track one another for many individuals. There's a correlation or relationship, but some individuals have brain ages that are a lot older than what their chronological age suggests, or some individuals might have a younger brain than what their chronological age would suggest. It depends on a lot of factors. It's complicated, but basically the brain is just aging differently for different individuals. Now the question is whether we can reverse brain aging. I'm not sure if we can reverse, like, can you turn a 40-year-old brain into a 20-year-old brain? I'm not sure. Yeah, I don't know if that's possible. I'm not sure right now. I don't think it is, but I'm not sure if it's even possible in 50 years time. I think what you can do is you can slow down your brain age potentially. Yeah. So a lot of the factors I mentioned, diet, nutrition, sleep, and so on, sleep in particular, right? They can actually help decelerate, meaning make your brain age younger, so to speak. Whether you can reverse it, I'm not sure yet. But this is a very exciting concept in neuroscience research, the concept of brain age. Brain health and brain capital. In the last year or so, there's a concept of brain capital. We are basically walking brain capital, and we need to protect our brain, so to speak. Yeah. Okay. All right. Zechelo is asking, how can the course provide opportunities to apply knowledge and practice at work or other places? Okay. We have a very strong application and translational component is built into each of the courses. So we don't just lump them all together into one course at the end, how to apply. No, we actually apply it within each course. So for example, today's talk came from the foundation course, 901. It's called 901, this foundation course. And we have a significant amount of application there when we think about how we want to apply some of these findings to our practice, not just in schools, but also in broader learning environments. So for example, at home, because we also learn a lot from home, right? When we're home, in offices, in corporations and companies and so on. So we do build it into each of the course, within each course to apply. I'm just trying to find more questions. So Heatherway is asking, are there any books that you recommend for people without background knowledge to better benefit from science of learning? Yes, there are quite a number of books. What we do is when students register and matriculate, even before they come, I share this folder that has got books, digital books. It's got links to videos of talks about the brain and learning and so on, that students can, at a very low effort level, it's not very intense. They can just watch and read some of these resources when they're free. And some of them are actually Netflix videos and so on. Yes, there are books. The best I can recommend for teaching and learning would be what I showed earlier. So these are some of the best books. We do cover them in the course, but if you're interested, you can try to look up some of these resources. The one about emotions, social emotional learning is sort of my area of expertise. I would recommend the book by Lisa Feldman Barrett. If you just Google how emotions are made. So again, how emotions are made. It's not here, but it gives a very accessible understanding of emotions that potentially will challenge what you think are emotions. And she does a very good job of trying to challenge your beliefs and making you think of emotions in a different way, including the fact that it can definitely affect learning. Do we have time for one more, maybe?
Yes, of course,
Questions?
definitely.
Yes. Let me see. Okay, so there's a question about starting school too early because our system is brain unfriendly. Yes, it is very brain unfriendly. If you observe around you, our public school students are the only students in Singapore going to schools before the sun comes up. Students in international schools and other kinds of systems, they go to school a lot later, and they're onto something. And it's because they know that some of these factors affecting health are truly important for development, neuroplasticity, and so on. I know schools in Singapore start early because of legacy issues and so on. It's very hard to change, but this is something that we get into in the course of how to think, not just implementing changes in our classroom, but also thinking at a broader level, effecting changes at the family, society, and the national level. Because part of the hope of our part of the goals of this program, right, is to have a broader view of learning, not just about what goes on in the classroom. As I tried to share, right, earlier, teachers are brain surgeons or neurosurgeons. Learning is not about teaching. It's broader than that. We have to have a broader view, and to MOE's credit, they do have a broad view of education, but sometimes the view doesn't translate into what's happening in the ground or at the ground level, and we have to sort of alignment between the two. Yep. So that's again another goal of the program, to think of learning not just within a classroom, what goes on in the classroom, but also holistically, what happens outside of classroom and all these other factors that affect the brain, mind, and learning. Okay, I think that might be all. Maybe I might take one. Oh, I think I saw a question about the kind of backgrounds, right, you need to have to enroll. I just give a sense of the profile of our students, and I have to say majority don't necessarily have a STEM background. They don't necessarily have a science, technology, engineering, and math background. Some do, but not all. So don't feel afraid of thinking of applying because you don't think you have a background in science. It is a Master of Science, right? Formally, it is a Master of Science, but we will guide you along and inculcate in you sort of scientific literacies, scientific ways of thinking about learning. You will interact a lot with the LKC School of Medicine faculty. You will get to learn a bit about fMRI. You get to visit, you get to use some of the tools, some of the equipment and technologies and so on, but we will guide you along the way. So even if you don't have a strong scientific background, which is what we see with our current cohort of students, you will get to grow and learn to be sort of, again, the next generation of learning designers with sort of a strong science of learning disposition and knowledge and skills. Okay, I think I'm gonna stop here because it's already 1:15. I apologize for not being able to address all of your very interesting and very difficult questions. I will try to follow up via email, and we can keep a conversation going. Yeah. I think that's it from me, unless Hiron and our graduate office would like to
Thank you,
say a few
Dr.
words.
Farhan, for your
Yep.
time. Well, just looking at the number of questions we've received, I'm sure you all have agreed that this has been a very interesting and insightful session for all of us. So if you've enjoyed today's session, we will now invite you to participate in our feedback poll. Please give us your honest feedback so that we can further improve on our Master's Experience series. The feedback poll should be popping up on your screen, so please take a few moments to share with us your observations. Just a couple of seconds more before we wrap up the session. Great. Thank you very much for your feedback. This Master's Experience series is proudly brought to you by HeadHunt in partnership with National Institute of Education, NTU. Thank you for joining us in this 14 sessions of Master's Experience series. Do join us at our next Brown Bag session, which will be starting on the 5th of April. Please keep posted on HeadHunt's Facebook page, and registrations will open in mid of March on our website, masterclass.sg. It has been wonderful having you here today, and on behalf of HeadHunt, we would like to wish you a wonderful weekend ahead. This is Tammy signing off. Thank you.